Welcome, and this is your physics class, and your tutor is Black Adam 5D tutor, and we have a problem that's based on the projectile motions. You can also call them kinematics. That's up to you, and it's a 2-dimension. And you throw a ball toward a wall at speed of 20 meters per second. So there's a man throwing the ball up to that. Okay, hits the wall somewhere, and then what we need to know, we need to have all the details analyzed, which is we keep our statistics. Initial speed, which is 25 meters per second, and that's our initial initial speed. So our initial angle, the angle at which we thrust the ball, that was at 40 degrees, and then we have the range, which is the distance, the horizontal distance that the ball traveled. The horizontal distance is the range up to that point, so that's changing. T will be change of the time it takes for vertical motion is also the time it takes for horizontal. So we know that we have 22.0 meter for our range, and then we want to get the time for the horizontal motion, so that we apply the same time on the vertical one, so that we can get our answer. So change in horizontal, that's 22.0 meter, and then horizontal velocity is time times initial velocity horizontally. So that's to say horizontal, okay, that's speed is equals to distance is equals to speed times time. So our distance would be horizontal distance, so it's v subscript x multiplied by initial velocity times cos, so we apply cos theta there, and all that multiplied by time. That's the initial velocity there. And then we have a distance, which is initial velocity times time, and then to solve for time is going to be distance divided by the speed. So that's our horizontal distance given, and that's 22 meter, and then initial velocity, that's initial velocity cos theta. So we have 22.0 meter per second. 22.0 meter divided by 25.0 meter per second, all that multiplied by cos 40 degrees, and we just punch in the calculator to find our answer. So that would be 22 divided by 25.0 multiplied by cos 40 gives us 1.148. so to 3 significant values figure, so that's 1.15 second. So that's the time it took to travel the horizontal distance, which is the time it took for the range. And then coming back there, we have to solve how far above. So they want to know the vertical distance that it covered. So vertical distance will be change in y is equivalent to initial velocity multiplied by sine of the thrust angle multiplied by time minus a half of gravitational acceleration multiplied by time squared. And we know that change in y is going to be 25.0 meter per second, multiplied by sine 40 degrees, sine 40 multiplied by time, which is 1.15 second, minus half 9.8 meter per second squared, and then multiply by time, which is 1.15 second squared, and all that. We should find that part there. So sometimes patching it once won't be helpful, so that part will be 25 times sine 40 multiplied by 1.15, giving us 18.48 to so we're not rounding off yet since it's not our final answer. The unit cancels, second cancels each other, and we have meter, so that's gonna be 18.48 meters. So we simplify that part. That will be 1.15 squared multiplied by 9.8 divided by 2, that's 6.480. So it's gonna be 6.48 meter. So 18.48 minus 6.48 gives us 12. So that's going to be 12 meter. And that's our answer. That's the horizontal distance. So it traveled 12 meter above before hitting the wall. The next question will be horizontal component. So horizontal component of the speed. So that will be initial velocity is going to be Vx is going to be VO, which is the initial velocity, times cos 40 degrees. And that's it. So we don't have the acceleration effects on horizontal movement, so that's going to be 25.0 25.0 meter per second multiplied by cos 40 degrees. So simplifying that will give us 25 multiplied by cos 40. Okay, that gives us 19.15. So 19.15. So rounding off to 3 significant figures, that's 19.2. And then we move on to the next question, which is the vertical component. So the vertical component has the acceleration effect on it, since the acceleration is a vector that affects vertical movement. So we have V vertical will be, that is Vy, y for vertical, and as initial velocity multiplied by sine theta minus acceleration multiplied by time. So that's going to be 25 meter per second multiplied by sine 40 degrees. So that's going to be sine 40 degrees, and then minus, it's going to be minus 9.8 meter per second squared. All of that multiplied by time there. Our time is the time that we found out, Ty is 1.15. So the time is the same, that moves 2 dimensions at the same time. So 1.15 second there, and then simplifying all that looks simple. Then 25 times sine 40 minus 9.8 multiplied by 1.5, and that gives us 4.79, which is going to be 4.80. So it's going to be 4.80 meter per second. So that's our answer for C. Next we have D. D says okay, that part there and that part, remember. So we have that part which are different signs, so that means it has an effect on each other. Now we have initial velocity sine theta minus g multiplied by time. So that one there, let's call it A, and that part there, let's call it B. So that part, if we have A in that part there greater than, we have B greater than A, that means our horizontal speed, our vertical speed is going to be negative. So because it's negative, it means that it passed the highest point, because the highest point is 0. If you haven't reached the highest point, it becomes positive. So highest point is negative and it passed the highest point. Okay, so there, if B is equals to A, we have V, our vertical number as 0 if they're equal. So it's exactly at the highest point of the movement. And then if we have B less than A, we have a situation where the vertical component is going to be positive, and that means that it's not passing, it's not passing the highest point, so it hasn't passed there yet. So that means that's our answer there, B. So our B said it did not reach the highest point before it hit the wall. So that's it, and this is your tutor Black Adam. As always, to show some token of our appreciation, I wouldn't mind if you would, for example, subscribe or follow. If it's on Facebook, please follow. If it's on WhatsApp, if it's on YouTube, don't forget to subscribe. Thank you so much. Any comment you can leave below. This is your tutor Black Adam 5D tutor. Thank you.